Hi, my name is Giles Owen Javier, and today I'm going to be talking about extraction. What is extraction? Extraction is a separation process that involves transferring of a compound from a solid to a liquid into a different solvent or phase. The most common type of extraction used in chemistry laboratories is liquid-to-liquid extraction, which is usually performed in a separatory funnel. This here is a diagram of a separatory funnel which is used in the experiment of extraction of different liquids to separate different liquids. The liquid-to-liquid extraction. In liquid-to-liquid extraction, a solution with the dissolved components is placed into a separatory funnel and an immiscible solvent is added. After it is shaken, two layers will appear, the aqueous layer and the organic layer. These two are separated by draining one of them from the funnel. The simple extraction procedure. First, obtain a separatory funnel, then place it in a ring and attach it to a ring stand. To ensure extra safety, place pieces of slit rubber in the metal clamp. Before pouring the liquid, ensure that the stopcock is closed. This can be noticeable when it is horizontal. Use a funnel to pour the liquid into the separatory funnel. Then pour the designated amount of extractive solvent into the funnel. Swirl the mixture or invert it with one hand covering the stopper and the other hold to the bottom of the funnel. To relieve pressure, vent the funnel by opening the stopcock for a little bit. Close the stopcock, then mix repeatedly with venting in intervals. After mixing a few times, return the separatory funnel upright to the ring clamp in order for the layers to fully separate. Open the stopcock and drain the bottom layer into an Erlenmeyer flask, and stop when the interface is within 1 centimeter of the bottom of the stopcock. Drain the top layer into another clean Erlenmeyer flask. Ensure that the two flasks are labeled properly. Clean up the apparatuses used with acetone before storing away. The uses of extraction. Extraction of natural compounds. This is, for example, extracting essential oils from fruits and plants. The other two uses can be transferring compounds from layers and selective removal of components. The partition coefficient. The partition coefficient, or K, is the ratio of concentrations of a solute in two immiscible liquids when it is in equilibrium across the interface between them. To calculate, one uses the formula K is equal to molarity in organic phase divided by the molarity in aqueous phase. And that is all for this presentation. Thank you so much.